Hi everybody, this is Dr. Suguna. This video is about how to write algorithm for show of hands problem. First let us understand what is this show of hands. So suppose that you are given a set of n persons, one among them will be randomly chosen as a nominee and he will pose an argument. All other persons except the nominee will show their opinion by raising or not raising their hands. If they raise their hands, it means they agree with the argument. If they don't raise, they disagree with the argument. Then finally, if the majority agrees the argument, then the output should be declared as argument wins or it should be declared as argument fails. Let us understand this using a scenario. Assume n is equal to 8, where n refers to the number of persons. So we have 8 persons and there is a judge. So here the judge is our computer, which will finalize and declare whether the argument wins or loses. So initially the count, that is the number of votes, is 0 and then you have to select who is the nominee. So as I told you, 1 among n will be the nominee. Let us assume this person is a nominee. Now she is posing an argument. Computational thinking is beneficial for students. Do you agree? Computational thinking is beneficial for students. Do you agree? Now this judge, our computer, looks at the first person and he has raised the hand. So what happens? How do you recognize this raising hand signal? We will be using one variable. That variable will be 1 if the person raises the hand or 0 if the person doesn't raise. So since he has raised the hand, the computer increments the count. That is 1. Next it looks the next person. She is also raising the hand. So 1, signal is 1. So incrementation is done. Next third person, he has not raised. So 0. Then fourth person, he has raised the hand. So the signal is 1. Incrementation will be done. Next person is a nominee. So we don't consider her. Go to the next person, he has raised. So the value is 1. Increment. Next person raised. Value is 1. Increment the count. So it becomes 5. The last person has not incremented, not raised. So it is 0. Now how do you decide the majority? The majority is nothing but you need to check count is greater than n by 2. That means we are checking for 50% majority. So if the 50% of n tells that they agree, then we declare this argument wins. So now we are checking count is greater than n by 2. What is count? 5. 5 is greater than n by 2. 5 is greater than 4. We are checking yes. Then we declare that argument wins. Now look at the other scenario. Again we have n is equal to 8 and now she is posing the argument. Algorithm development is easy. Do you agree? So the observation starts from the first person raising. So indication is 1. Count is incremented. Next person raising. So it is signal is 1. Count is incremented. Third person not raising. So it is 0. Fourth person not raising. Then nominee we skip. Then next person is also not raising. Then this person is raising. So the signal is 1. Increment the count. And the last person is not incrementing. Now you check what is count. Whether this count is greater than n by 2. Now we will get the answer as no. So the final declaration will be argument fails. So this scenario, how to build a logic for this? So what is your input? N. N is the number of persons. So what are the process we are going to do? So first, we will be using a variable to denote the nominee. So let nominee, how do you select the nominee, is equal to random of 1 comma n. Next, we use a variable to count the number of persons agree the argument. So that variable is what we name it as count, and initially count is equal to 0. Next, we use a variable to refer the persons. So let it be I, where I is equal to 1 is initialized because I initially starts with the person 1. Then we need to repeat the following steps if I is less than n. So if the person is not a nominee, then you have to read the hand signal. Hand signal could be 1 or 0. If hands is equal to 1, then increment the count by 1. Then after doing that, increment I by 1, which means that you go to the next person. So if it is not the nominee, you have to do this process. If it is a nominee, then you will be skipping that person. So just increment I by 1. Then you have to check for majority. So the majority is checked with count is greater than n by 2 and declare the result. So the output will be argument wins or argument loses. So let us turn this logic into the algorithm. So how do we write the algorithm? Step 1 begins with start. 2 is the input. So here we are reading the value of n. Then you are computing the nominee, that is equal to random of 1 comma n. And we will be initializing the count to 0, I to 1. Then you will be checking whether I is not equal to nominee. If yes, you have to read the hands value. Go to step 6. If it is equal to nominee, then you have to go to step 7. So step 6, we have to read the hand signal whether it is 1 or 0. So check hands is equal to 1. If it is yes, increment count by 1. Then increment I by 1. Then we will be checking whether we have finished all the persons observation. So we are checking I is less than or equal to n. If it is yes, go to step 5. That is less means still some more persons has to be observed. So go to step 5. Otherwise you will be going to next step, where you will be checking for the majority. So check whether count is greater than n by 2. If it is yes, go to step 10. So display the argument wins, and then you need to stop. Otherwise in step 11 you have to display argument losses and stop. So this is how the algorithm can be framed, and this situation tells you how to convert the real-time observations into a input to the computer. So thank you for watching. Subscribe.